Hello, I'm Yoav Shoham. I'm a co-founder and co-CEO of AI21 Labs. I want to speak about accuracy and LLMs. We all know and love LLMs, and for good reason. They really are amazing. But they're brilliant. They're brilliant 95% of the time. And then 5% of the time they're not. And when they're not brilliant, and not just a little bit wrong, they can be ridiculous. And maybe that's okay if you're a student turning in your homework based on an LLM, likely nobody will read it anyway. But in the enterprise, if you're writing a memo to your prize client or your boss or your doctor, writing a diagnosis, if you're wrong, that the cost of failure here is catastrophic. And so that won't fly, not in the enterprise. And the problem gets worse because we don't just call LLMs, we do more complex flows. For example, this is a relatively simple RAG or retrieval augmented generation setting where the LLM, based on the input, decides to call an external database or some information source. The information source retrieves some information, and based on that, the LLM decides on the output. Each of those has a certain error probability. The problem is they compound. As the errors compound, the accuracy drops. And these days, when we get into agent, a loaded term and worth discussing separately, when we have these complex flows that not only have multiple steps, but also multiple tools, these errors compound so much that at some point you get more noise than signal. And this just won't fly in the enterprise. This happens to be a study from AWS from 24 that showed that of all the pilots taking on the enterprise, and we have, some of our clients have hundreds of use cases they're looking at the number of those that see the light of day all the way to production is small. In this study, they showed it was 6%. And so that's a problem. And if we want enterprise to truly adopt AI and deploy it at scale, we need to deal with the problem of reliability. To sum it up, we have a serious problem of reliability, and that's really holding back the enterprises from deploying it at scale. So how do we do this? Let's try to get the LLMs to behave through a variety of techniques. Fine-tuning and alignment, very complicated system prompts that we hope will coax the LLM to behave. And they all have a role, they're important. But none of them, or even together, won't get you to the reliability you want. The alternative is to understand that the LLMs are a critical component, but a component of the complete AI system. AI system that understands the task, breaks it down, calls LLMs where appropriate, the right LLMs where appropriate, others at other times, call tools, call custom code, and orchestrates all of that. So what do we do about this problem of inaccuracy? Some would have the LLMs behave through a variety of techniques. Fine-tuning, alignment, very complicated system prompts that somehow together should somehow coax the LLM into the behavior you want. And they all have a role, they're important, but they won't get you to the reliability you really need in the enterprise. The alternative is to realize that LLMs are a critical component, but a component of a complete AI system that calls LLMs, the right LLMs at the right time, call tools, does validation, and orchestrates all of this in a way that controls for accuracy and also the cost involved. So this is the approach we've taken at the company, and increasingly the direction that the industry is going. So for example, you have here a fairly simple prompt input to the system, asking you to speak about sales through a span of years and with some properties like excluding software and services. And you see on the left side, the response of a very well-known solution from one of the well-established companies, and it's just wrong. All the orange is wrong. And when you put it in an AI system, the system is smart enough to check itself, to go and do the various things it needs to do and get the right answer. Because this slide shows you some experimental results that show how AI system help in a control setting. For example, the top ones show how it increases reliability of instruction following. On the right, you have a well-known benchmark called IF-eval and you see that in the white, you have the output of a standard well-known system. And when you wrap around it Maestro, a particular AI system, you dramatically increase the accuracy. The two different thing charts, one is when you use a certain kind of system that uses what's called a judge language model, and the other when you use code for verifiers. Details aren't important. The point is that you significantly increase the reliability, and the left charts on the right does the same thing. The bottom chart shows it in a different setting in another well-known benchmark from Google called Frames. This is a RAG setting, and again, the story is similar. By wrapping an LLM call in an AI system, you have a dramatic increase in accuracy. And that's it. To summarize, accuracy, a big showstopper in the enterprise. To really deal with the problem, you need to take an AI system approach, and that is increasingly what you'll see in the enterprise. Thank you.